Back in 2017, something absolutely extraordinary streaked through our solar system. It wasn't a comet we knew, or an asteroid from around here. It was our very first confirmed visitor from another star. But this visitor, they named it Oumuamua, left astronomers with way more questions than answers. All right, let's dive into this incredible cosmic mystery. So naturally, the first thing on everyone's mind was, what did this thing even look like? You know, when you picture a comet or an asteroid hurtling in from deep space, you probably have a pretty clear image in your head, right? A big lumpy ball of rock and ice? Yeah, no. Oumuamua was nothing like that. Not even close. It basically broke every single model and defied every expectation we had for an object coming from another star system. I mean, this was a huge moment for science, our first confirmed guest from interstellar space. It was solid proof that objects could actually travel across the vast empty oceans between stars and pop in for a visit. So it was officially given the name One-Eye Oumuamua, and that eye in its designation, that actually stands for interstellar, marking it as the very first of its kind we'd ever seen. And right away, it presented scientists with this amazing puzzle. Because right from the get-go, this thing was just weird. It was breaking all the rules, it didn't look right, it didn't move right, it didn't fit into any box we had. Just look at this comparison. It really shows you how bizarre this thing was. We expect a typical comet to be roughly spherical, you know, a big, dirty snowball of water, ice, and rock. Oumuamua, on the other hand, was tiny, either super elongated like a cigar or flat like a pancake, made of almost pure nitrogen ice, and it was moving much slower than our theories predicted it should be. So these were the clues astronomers were working with. A really strange shape, a weirdly slow speed, a totally unexpected composition, and it was teeny tiny. Every single clue just made the mystery deeper. How could one object be so different from everything we've ever seen? But then, a new theory came along that was just as elegant as it was absolutely mind-blowing. What if Oumuamua wasn't a comet or an asteroid at all? What if it was a piece of a planet from another solar system entirely? This quote from Steve Dish over at Arizona State University just nails it. He and his team basically said, hey, wait a minute, everything about this thing looks like it's a slab of frozen nitrogen, just like the stuff that covers the surface of Pluto. Just let that sink in for a second. We might have been visited by a chunk of an alien Pluto. And that brings us to this idea of an Exo Pluto. It's pretty much exactly what it sounds like. A dwarf planet, a lot like our own Pluto, covered in nitrogen ice, but orbiting a completely different star, many, many light years away. So how does a piece of an Exo Pluto end up in our galactic backyard? Well, you have to imagine a young, messy solar system. It's kind of like a game of cosmic billiards. You've got giant planets forming and throwing their gravity around, jostling smaller worlds. And then, wham, a huge object smashes into an Exo Pluto, chipping off a big slab of its frozen nitrogen surface and launching it out into the void of deep space. Now, here's the truly amazing part about this whole Exo Pluto idea. It explains everything. Let's just break down how this one single theory solves every one of Oumuamua's strange little quirks. Okay, first, the speed. Remember how it was moving slower than we expected? Well, if it got kicked out of a young star system, that system just hasn't been around long enough to get accelerated to high speeds by the galaxy's gravity. It's still moving relatively slowly, and that slow speed gets passed right onto the fragment. Mystery solved. Next up, the composition. Why was it made of nitrogen ice instead of the usual water ice? Well, because it wasn't a comet that formed from a generic cloud of gas and dust. It was a literal piece of a planet's surface, scraped right off an alien world, that, just like our Pluto, happens to be covered in tons of frozen nitrogen. And this is just incredible. As the slab of nitrogen ice zipped past our sun, the heat caused that ice to vaporize fast. Scientists estimate that it lost more than 90% of its entire mass during its very short trip through our solar system. And that massive evaporation, well, that's the key to the whole thing. Because that rapid boiling away of ice explains the final mystery, the shape. As the nitrogen turned to gas and blasted off the surface, it eroded the object, thinning it out and sculpting it into that weird, flat, pancake shape that had everyone so baffled. It's kind of like a bar of soap that wears down and gets thinner and thinner every time you use it in the shower. So when you put it all together, You get this absolutely epic journey. Maybe 500 million years ago, a massive collision in a young star system out in the Perseus arm of the galaxy sends this fragment flying. It travels through the cold, empty space for ages before it makes one brief pass by our sun, where we were just lucky enough to spot it. But you know, solving the mystery of this one object isn't the end of the story. Not at all. In fact, it's just the beginning. It suggests we've stumbled upon a completely new type of object out there in the universe. Like Steve Desesh says here, we really should have been expecting this. I mean, our own solar system probably ejected countless fragments just like this when it was young and chaotic. The fact that we found one so quickly after we really started looking suggests that interstellar space is probably littered with these things. So, why is this such a big deal? Well, it means that pieces of other solar systems, fragments of alien worlds, might be really common visitors. And get this, because nitridal ice is super reflective, they're actually easier for us to spot than we thought. By studying them, we can get a direct look at the building blocks of planets around other stars without ever having to leave home. How cool is that? And believe me, the hunt is on. We have new, incredibly powerful telescopes coming online, like the Vera Rubin Observatory, and they're specifically designed to scan the entire sky for exactly these kinds of fast-moving, transient objects. We expect to find a lot more of these interstellar messengers. Which leaves us with this final, just amazing question. Oumuamua was the first one. How many more pieces of distant alien worlds are drifting through the darkness right now on a course that will take them right through our solar system? We just have to be ready, and we have to keep looking up.